With the release of version 7, we've implemented hierarchical design. From this point forward, we will be referring to it as HD. This is possibly the largest feature that we've implemented for version 7. And we're going to work through a rather contrived example, but that will illustrate how we can work with this new methodology. So this is the first page of our schematic. We're going to go ahead and add in a frame, so that way we can establish our work area. We're going to go to the frames library. We're just going to pick a letter sheet, something that we could easily print. We go frames, letter, landscape. Obviously we have the normal standard paper sizes for both the US and Europe. Click OK. I'm going to go ahead and place it. Okay, let's do a window fit. Now at this point, normally users would just start placing in the various components they need to use to develop their design. In this case, we want to make an HD based schematic. So throughout this design, we're going to be using two modules, a power supply module and a very simple oscillator module. This sheet 1, will form the basis of our hierarchy. And then the subsequent sheets will be the modules that we will enter into this main sheet. So to start, let's go ahead and define a module by clicking on the module command. And we're going to define a power supply module, power supply, module. Ego says it doesn't exist. Do we want to create it? We say yes. I'm going to place one right here. Okay, I press the module command again. And we're going to make a very simple oscillator module, OSC. Okay. It says doesn't exist. Do you want to create? We're going to say yes. I'm just going to place this one over here. So we've established our two modules that we're going to be working with, an oscillator module and a power supply module. Let's go ahead and start working on the power supply module. As you can see, power supply module is defined as its own sheet. Within modules, you can define additional sheets. I could go right here, for example, new, and add another sheet to the module. So there's no limit. You can make a very complex module, you can make a very simple module. For our purposes, one sheet's going to be more than enough. So I'm going to remove that sheet. Say yes. I'm going to work with our power supply sheet. I'm going to go ahead and add another frame in this sheet. Just again to establish a working area. There we are. And let's go ahead and add the components for our power supply. And our power supply, this is going to be very, very straightforward. We're going to add a 7805 regulator and the supporting passives. Just going to search for it. Okay, let's see. Where is it? And here we are. Positive voltage regulators. I'm going to use the 805Z. That's fine. Click OK. I'm going to place it. Okay, whoops. It escaped too many times. Let's go ahead and put in our passives. Okay, I'm going to clear this. Okay, our passives are in the RCL library. Just two simple little 0805 capacitors, ceramics. This particular regulator uses very low value capacitors, so we don't need a very big package. Okay, let's place one on the input and one on the output. There we are. I'm going to go ahead and now put in supply symbols. Within modules, the scope of a supply symbol is that very module. It won't extend outside to the higher level of the hierarchy. Okay, so keep that in mind. When you use a supply symbol within a module, it's going to be restricted. Its influence or its scope is going to be restricted to that module. Important thing to keep in mind. So I'm going to go ahead and use a supply symbol here. Alright, there we are. And I'm going to use a net command to just start making those connections. There we are. Perfect. So let's give some of these nets names. That'll simplify making the port connections later. So I'm going to name this net VN. This net will be named VOut. Or I'll name it +5 volts. And obviously we have ground. Very simple. So let's go to our main level schematic. And now here on the power supply we can add ports for these entries. Okay, so we're going to use the port command, which is this one right here. We're going to click on the power supply and we're going to select what nets we want to bring to the outside. In our case we want to bring them all. So we have VN. We're going to place VN, let's say here. Okay. We'll click on ports again. We'll bring in ground. Okay, let's put ground right there. Click on ports once again. And we'll select +5B. Okay. We'll put it more or less the same level. Now if we look closely, these are set up as being bidirectional. Okay, all of these ports right now are set as input and output. And we can change those settings doing an info. And we see here we have directions for each of these. We can make adjustments to them individually. There we are. By doing a control left click, I'm going to select obviously the end to be just an input. We click OK. Now we have an input. The ground, missed the pin again. Control left click. There we are. The ground, we'll make it a power. We'll click OK. And this will be make this either a power or an output. So I think for this purpose I'll make it a power. And we hit OK. So now we've defined this block. This block represents everything that is defined on this sheet. Very simple. So we've been able to abstract the complexity of this circuit, even though this one is very complex, into just a block and 3 terminals. That's all. Now in a simple circuit like our power supply in this case, there's not much sense in doing that. Our oscillator circuit is going to be a tad more sophisticated, but again, very simple. I'm going to go to the add command again. I'm going to bring in a frame. The frames library. Again, we'll use a letter size frame. We will click OK. There we are. And our oscillator in this case is going to be just a 555 timer in a stable mode. Very straightforward. So in our case, the 555 timer is in this linear library over here. I'm going to use the surface mount version. Click OK. Place this one over here. And I'm going to bring in the passives. And again, those will come from the RCL library. So for this circuit, I need a total of 2 resistors and 3 capacitors. There we go. Again, I'm going to use a 0805 capacitors. This is what I tend to use in my own designs. It's about as small as I would prefer to go if I have to hand assemble. I can do 0603, but if I can stick to 0805, it's just easier. Okay, let's go ahead and place our 3 capacitors. And we'll put in 3 resistors, 2 resistors as well. Again, these will also be 0805s. Okay, there we go. One here, one here. So I'm going to use the move command, try to organize everything. More or less the desired location. It's again, very simple example, a little bit contrived, but it's enough to illustrate how this methodology works. Put one here. It's there. This will go there. Okay. Going to use the net command to make the connections. We can right click to change the wire bend style. Okay. There we are. Okay, let's go ahead and put in some power symbols, some supply symbols. Again, remember their scope is limited to the module itself. Okay, put another one here. Okay. Going to place a ground symbol. We're also going to place, let me make a copy over here. This one up here. There we go. Let's make our connections using the net command again. Okay, equal warn. We say yes, we want them to connect to ground. Let's connect to V+. Yes, we do. Same thing over here. Okay. Let's go ahead and assign values for our design using the value command. Most of these are straight from the data sheet. This is 0.01 microfarads. It's just a bypass cap, so 0.1 micro. This one I calculated to be 1 micro for the application, which is just a very simple little LED blinker. Okay, this one will be 450K. This one will be 100K. Okay, let me see if I'm missing anything. Okay, here we have the last net over here. And additionally, here on the output, I'm going to put this net and I'm going to name it. Because this net is important for our application today. Out. It's named. I'm going to put a label on it. Place it right there. That's fine. Okay, and now this circuit is complete. So now if we go to our first sheet again, look at our oscillator. We activate the port command. Click on oscillator 1. Okay, what nets do we need out of this one? Well, definitely need the power rails to be able to activate the part. So I'm going to place this here. like to place the ground net. As you can see, we could place any of the internal nets of the module. In our case, we just want to make sure we get the ones that are inputs and outputs. That's what allows the abstraction to work, to be effective. To take away all of the internal complexity of the design and just reduce it to inputs and outputs. Okay, let's go ahead and establish the final one, which is the output. And there we are. So again, we use the info command and we do a control left click on the pin itself to be able to change direction. Ground will make power. Okay, V plus will also make it power. And then for the output will actually be an output. And there we are. Now it's important to recognize that on the top level schematic, you're not strictly limited to just the power supply, just the modules. You can actually put components on the top level. So in this case, what we're going to do, I'm going to go ahead and use the net command. I'm going to connect from here to here. There we are. Going to connect the two grounds. Now again, I could use supply symbols at this level. They won't interact with the ones internal to the module. So I'm going to go ahead and do that. There we are. Let's go ahead and add a connector for our power to come into the board. So there's lots of connector libraries in Eagle. They're all prefixed with CON for connector, and then they're organized by manufacturer. But for a simple 0.1 inch header, which is what we're going to use in this example, we can use a pinhead library. 1x2, click OK. There we are. Make a copy of our ground symbol. Place it over here. Use the net command. There we are. Perfect. Now for the output of our oscillator, the one thing all makers love more than anything else, LEDs. Gonna place current limiting resistor in LED. So LED, gonna use a 5mm LED. Place that right here. Place an 0805 resistor. And that will pretty much end our design. CL, US. There we are. By right clicking, I can rotate. Let me move these around a little bit. There we are. Use the net command. And a copy to put in the ground symbol for this one. There we are. So that's our finished design using the HD methodology. We have two modules, a power supply and an oscillator. We can see the internals of those modules by clicking on the appropriate sheets. And let's go ahead and make a board based off this schematic. We're going to click on the switch to board icon. He was going to say it does not exist. We create from schematic. We say yes. And there's our design. Now we can arrange them, modify them, put them wherever they need to be in order to make our board. So that's the basic introduction to how HD design works in Eagle. Essentially, it's all schematic based. It's a means to organize. You define what modules you want to create. In their own individual sheets, you define them and just extract or abstract the inputs and outputs. That's the goal of HD design. What are the benefits? Well, if you notice, the main level of the schematic almost looks like a block diagram. So it helps with the readability of your design, with the legibility of it, being able to understand the flow. Additionally, these different modules can be imported from other designs. So in a large team, you can divide the work by modules. Engineer A has the power supply, Engineer B has the processor, Engineer C has the sensors. And they can work on their designs independently, form a module, and then whoever has to integrate the whole system together can then take these modules and put them together for the finished design. So these are the benefits. Feel free to contact us, support@cadsoftusa.com, or to give us a call at 954-237-0932. Thank you very much.